Let's take a look at some functions. The easiest way to think about a function is to consider it as an input-output machine. The domain refers to the set of possible input values. So for instance, this could be 3 or -4 or any other value that we would put into a function. The range is the resulting set of possible output values. So for instance, if we have a function f of x which simply squares the input, then 3 in the domain will map to 9 in the range, and -4 in the domain will map to 16 in the range. Input on one side, output on the other. Hopefully we've seen function notation before and we're able to evaluate, because where I'm looking at f of 1, all I'm interested in is that function evaluated when x is equal to 1. So 6 multiplied by 1 subtract 4 is going to give me 2. If I look at the function g, it's no different, so there I'm looking at -3 squared plus 5, which is 9 plus 5, which is 14. Lastly, we can solve questions where we have two functions that become equal to each other. So I take the value for f, which is 6x minus 4, and equate it to the value for g, which is x squared plus 5. Now I want to solve that. It's a quadratic, so I know that I'm going to make it equal to 0, and there we have x squared minus 6x plus 9, and factorising, that's going to give me x minus 3 all squared, so x will be equal to 3. In this example we've got a quadratic function, and the first thing that I'm after to do with that function is to write it in a completed square format. So we know we do that by halving the coefficient of x, so in this case -3, subtracting that value squared, and then take off the original constant, which is x minus 3 all squared, subtract 11. So p takes the value -3 and q takes the value -11. To find roots, well, as I've stated up here, a root is a value of x such that f of x is equal to 0. Important learning point. So if I want to find the roots of f of x, I want to find f of x is equal to 0. Or in this case, x squared minus 6x minus 2 is equal to 0. Now the first part of my question got me to complete the square, so I know that that can be written as x minus 3 all squared minus 11 is equal to 0, and then I can rearrange that to give me x minus 3 all squared equals 11, or x minus 3 equals the square root of 11. Now when I take the square root of something, obviously I get two solutions, one positive and one negative. So here are my answers, plus or minus the square root of 11. Lastly, I'm thinking about finding a minimum value for f of x. Well again, let's look at the completed square version. I want to find when this function, x minus 3 all squared minus 11, has its minimum value. Well, I know I can't ever change the value of minus 11, it's always going to be minus 11. This here, however, can change. It will take different values depending on the input of x. I know, however, that when I square a value, it's always going to be positive. So the smallest thing I can ever hope to make this would be 0. And that would happen when x was equal to 3. At the point where x is equal to 3, the first part becomes 0, the smallest thing it can possibly be, and then I subtract 11, so the minimum value is going to be minus 11. In this case, I want to find the roots of a different function. Now, initially when we look at this, we might think, ooh, that does not look like anything that we've seen before. However, this is actually a quadratic in disguise, and to show you that, we can make a substitution. Now typically in mathematics when we make substitutions we tend to use the letter u. I don't know why, but in this case I'm going to say let's let u equal t cubed. If I let u equal t cubed, then u squared is going to be equal to t cubed squared, or in this case t to the power of 6. So I could rewrite this equation, instead of saying that this is t to the power of 6 plus 9t cubed plus 8, I could say, well, that's actually u squared plus 9u plus 8. Now I want to find roots, so I want to find when this equation is equal to 0, and this is something that we can factorize. This is u plus 8 and u plus 1. So from this we would say, well, u is equal to negative 8 and u is equal to negative 1. Well, we made a substitution to say that u was t cubed, sorry. So this should really say t cubed is equal to negative 8 and t cubed is equal to negative 1. Now to find the original value for t, that's going to be the cube root of negative 8, and t here would be the cube root of negative 1, so t is either negative 2 or t is negative 1. Substitutions can help us find our solutions.